Welcome to speech enhancement course. In the last video, we have seen how to write or how to convert the speech waveform into a matrix form, right? So in this video, we will see what are the values stored in the matrix actually and how many values stored in the matrix, right? And what are the amplitudes of that waveform stored in the matrix. So that thing we will see. So here A is equal to audio read of sp01.wave. So by using this command, we have stored the speech signal which is of sp01.wave into the matrix A. So that you can see in this workspace here. So upon double click on this A, you can see the values. See, these are the voltage values. This is the first sample value, second sample value, all these things. So observe here, it is stored in the double format, and also it is 2.4414 e minus 04. It indicates that it is 2.4414 into 10 power minus 4. This is actually, that is minus 0.000244 is the actual value of the first sample here. Similarly, second sample is 5.7983 e minus 04. It indicates into 10 power minus 4. So that is equal to 0.0005798 is the actual value. That is, the values are around zeros here. So the same thing we have seen here after plotting the waveform here, right? So plot of A, we have seen the same thing here. So if you see the amplitudes level here at the very beginning, you will see here the first sample, it is very less value. So it is 0.000244, which is very less value here. So as we are moving here, right, so at around some 0 to 0.5, that is around here we are having some 0 point minus 0.28 value here. So as you move on, you can see the values here. So here minus 6.1035 e minus 05 indicates it is minus 6.1035 into 10 power minus 5. That is the actual meaning here. So as you are moving like this, here it is 0 amplitude here. So 0 amplitude here. So you can see here 0.2 like that, right? So like that you can read the values here, right? Now, so what is the meaning here as like actually? So how many samples you got here? So it is 22529 into 1. So that much samples you got here, right? See, that speech wave from sp01.wave is a continuous wave here, right? That is a sound signal already you have listened, right? So how we are storing means, first of all we are doing the sampling and then we are storing the signals here. Observe here that the total, see on the x-axis here in the plot, it is y-axis amplitude here, but x-axis here it is 2.5 into 10 power 4. What is this meaning of 2.5 into 10 power 4? If you calculate this one, right, so that is 25,000. See, that is, see, this x-axis indicates a sample value here, right? See, suppose I have talked, suppose 2 seconds duration, right? Time t is equal to 2 seconds duration, right? So but here it is not in seconds duration, it is not time axis, it is a samples here we have written. So that thing you can understand in a minute here. So I'm minimizing this one. So let us consider I am writing here statement like this: a comma some sampling frequency. See, sampling frequency here I am writing, see, a comma sampling frequency is equal to audio read of, see, sp01.wave. See, by executing this statement, you came to know that the sampling frequency value is 8000 is showing. What is the meaning of sampling frequency? 8000 means that is per 1 second it is storing 8000 samples. That is, out of, for 1 second the spoken speech, it is going to sample 8000 per each 1 second, right? So that is the sampling frequency. So that is, here in the waveform what we got here, the first 8000 samples indicates it is about 1 second, next 8000 2 seconds, so like that. So the time duration of this one is nothing but the, so how many samples it is having? So 22529. 22529 divided by 8000 is the actual time duration of the signal, speech signal. See, that is the point you have to note here. So on x-axis it is number of samples, and y-axis it is the amplitude. So this is the speech waveform plot here. Right. Suppose I have talked, suppose 10 seconds, and I have sampled with the 8000 sampling frequency. Then so 10 into 8, so total 80,000 samples you will get here in the x-axis. That is the meaning here. Right. So thank you.